Okay, thank you so much for the invitation. Good afternoon, ladies and gentlemen. As we have seen it from this question that you have had to answer before, there are many, many different possibilities for the use of hydrogen in the future. And there are very huge expectations and hopes from different stakeholders, different industrial sectors for the future use of hydrogen. And this leads at the beginning, even when we want to talk about urban use cases, to the question, is hydrogen the silver bullet for a climate neutral energy system of the future? And before we hop in that, let's start with a short SWOT analysis and let's take a look on what we can see in the strengths, weaknesses, opportunities, and in the threats for hydrogen. On one hand, the strength is that you can produce hydrogen with electrolysis in modular design by the use of renewable electricity without carbon emissions. And hydrogen is an energy carrier or energy source that can have a very high energy intensity regarding the mass. But on the other hand, the weakness is that you have a very low energy density regarding to volume, which could be a challenge for the future necessary storage and transport. And the production of green hydrogen is more expensive than the hydrogen that they use today in industrial cases, the so-called gray hydrogen from reforming, which is causing carbon emissions. And in many cases, the direct use of electricity is much more energy efficient than the use of hydrogen. So green electricity in the direct use will be one of the major competitors to the use of hydrogen in the future. But we see also huge opportunities for hydrogen because it's the so-called last resort energy source for the decarbonization of some sectors where there are no other or nearly no other possibilities for decarbonization. These are sectors in the industry, in heavy transport, and the long-term electricity storage, as I will show you in a few minutes. And one of the fine things and opportunities is that, at least partially, you can use existing energy infrastructure, for instance, from the existing gas supply system. But one of the threats we have to point out is that you need renewable electricity to produce green hydrogen, and the availability of renewable electricity may be scarce in the future, and there are many different other approaches which will use renewable electricity. And if we are not able to produce enough green hydrogen on a domestic level, we will create new import dependencies for our nation in Austria, but also for the European Union, because then we have to import green hydrogen from other areas of the world, like Northern Africa, for instance. And this could bring us in a competitive disadvantage because, for instance, when you look at Austria, we are a small landlocked country in the center of Europe. So transport infrastructure for hydrogen on a global level or on a level from between continents will be also scarce, and the location of Austria is not very attractive for that. In general, I want to point out that Austria has very high climate and energy targets. From the existing Austrian government program, we are focusing on reaching climate neutrality until 2040, which is 10 years earlier than the Paris Agreement timeframe would tell us. And in addition to that, we want to produce our electricity in Austria from domestic renewable energy sources in an amount of 100% on a national balance sheet until 2030. And for this case, we will need lots of new installations for renewable electricity generation in an amount of an annual generation of 27 terawatt hours. So when we talk about hydrogen in the future and our climate targets today, we have also to point out that we already use hydrogen, not for energetic reasons, but in processes, in the refinery processes, in the production of ammonia for fertilizers, and in the chemical industry. All in all, these are about 144,000 tons a year in Austria. And if you want to produce this as green hydrogen from electrolysis with renewable electricity, you would need about 7 terawatt hours of green electricity only to substitute the hydrogen that is already used in Austrian industrial sector, in industrial sectors. But there are other sectors which will need hydrogen to decarbonize, and one of the main sectors will be the iron and steel production. The iron and steel production on the level as we have it today in Austria will need about 425,000 tons of hydrogen, of green hydrogen, with about 20 terawatt hours of electricity, green electricity needed for the production of these hydrogen by electrolysis. And decarbonizing the iron and steel production in Austria is of utmost importance to reach our climate goals, because the iron steel production stands for about 15% of the overall carbon emissions of Austria. So if we would not be able to do this, Austria could not reach the climate neutrality target by 2040, and not even in a longer time frame. When we want to reach this 100% renewable electricity until 2030, and we will produce much electricity from photovoltaics and from wind power, in addition to the already existing hydropower in Austria, we will create an electricity system which produces much more electricity in the summertime than in the wintertime. So we will have a surplus with significant peaks in the production of the summertime, which you can see here on the left-hand side of this slide, with a summer week of 2030 and its production, which is very often much higher than the blue line, which stands for the electricity demand in 2030. On the other hand, we will have a lack of renewable electricity generation in the wintertime, which brings us to the point that we have to transfer and store electricity in the summertime to transfer it to the wintertime. The traditional approach for that in the moment is exporting and importing electricity. But when you consider that all our neighboring countries are also developing their electricity supply systems towards more use of renewable electricity, and our biggest partner for imports and export is Germany, which will have in 2030 a comparable electricity system as we will have it. So when we will have surpluses, we can expect that they will have also surpluses. So we will have to find a way to store this electricity in the summertime to have it available in the wintertime. And the approaches for that are with the use of hydrogen. The problem is that bringing 1 terawatt hour of electricity into the winter, you need a multiple amount of electricity in the summertime, because the production of hydrogen and the methanization, for instance, have significant losses, and also you have losses then when you produce the electricity from hydrogen, as you can do it with fuel cells, or from the synthetic methane with gas cycle, combined cycle heat and power plants. And these are the main power to gas to power solutions which we could develop until 2030 to solve this seasonal problem with our electricity supply system. But the good thing about that is that both of these use cases produce ambient heat which can be used in the heating sector. And this leads us to one of the, in my opinion, major urban use cases for the future. It's the use of green gas from hydrogen that will contribute to the decarbonization of the district heating systems. When we produce electricity from combined cycle heat and power plants during the wintertime, we can use the heat to feed it into the district heating systems. On this slide, you can see a decarbonization scenario for the Austrian district heating sector until 2050. You can see that there are already significant renewable energy amounts in this system so far, and these are the dark green parts with solid biomass, and this will increase in the future. But you can also see the yellow parts, which represent natural gas, which have to be replaced when we want to get a system that is carbon neutral. And here in this scenario from 2035 on, you can see significant amounts of green district heat from green gas is coming into the system. And when we remember that I told you that the new Austrian government program wants to have a climate neutral Austria in 2040, we will also have to accelerate the development of these green gas parts in the district heating system, because we have to reach the stage that is shown here for 2050, then already until 2040. So we can see there are many, many different possible solutions and approaches for the use of hydrogen, and we will need hydrogen in some sector in a very high priority, because there are no other solutions for decarbonization available there, especially in the industrial sector for heat processes for the production of iron and steel, but also for glass, ceramics, and cement. This leads me to my conclusions, and I want to tell you that hydrogen, unfortunately, is not the silver bullet for all these use cases in the future energy system, but it will be necessary and it will be playing a significant role in the energy supply of the future. We have to consider that there will be a limited availability of hydrogen because of the limits also for the production of green electricity, because also these potentials are limited, and this makes it so important that we have to look at the energy efficiency of all use cases for renewable energy in the future in general, but especially for the future use of hydrogen and green gas. And therefore, we have to use hydrogen concentrated in the hard-to-abate sectors where we have no other possibilities for decarbonization, and these are industrial processes, heavy transport, electricity, and district heating. And as I told you, district heating will be one of the urban use cases for hydrogen and green gas. But we will have new import dependencies that should be avoided, and therefore we need innovation. Technologies must be developed with research and development, that they will be available in the time frame from 2030 on. So that was my input to this session, and I think the colleagues after me will tell you some more detailed information about certain cases which they are working on. Thank you so much for your attention.